Hey students, welcome to our first video. This is 1.2. This is matter and substances. We are talking about matter and substances. So today's notes are going to be a lot of background information. Hopefully we learned a few of these already in our vocab that we did yesterday or the day before. So let's just jump right in. So our first step is we need to define what chemistry is. So chemistry is the study of matter and energy. So our focus is going to be on matter and energy. We'll spend a little time on energy, but the bulk of our year will be spent on matter. And so we probably need a definition of matter. And a definition of matter that we can use is something that has mass and takes up space. And remember that space we're talking about, that taking up space, is volume. So matter is anything that has mass and volume. Okay? So the bulk of our notes today are going to be our types of matter. We're going to break it down into two major types. We have pure substances, which means the composition is always the same. So this never changes. Wherever we are, this is going to have the same composition, never changing. It's always going to be the same, no matter whether we're here, we're in Western Kansas, we're in Colorado, we're in California, we're across the pond in England. It's always the same. Our first type of pure substance is our elements. Elements can be found on the periodic table. And they also have all the same atoms. So every single atom is the same. Same number of protons, same number of electrons, most of the time same number of neutrons, but we'll talk a little bit more about that in our next unit. Okay? Example of that is like zinc. All right? Its abbreviation is Zn, or we could just say ZnC, Z-I-N-C. All right? The element zinc. You could think of gold, oxygen. There's a ton of them out there. Okay? Our compounds then are specific ratios of atoms. So we have a combo of elements here, and they are in a specific ratio. And think of that ratio as like H2O, right? H2O, for us to have water, it has to be two H's and one O. Because if we have two H's and two O's, that makes it hydrogen peroxide, and that's two very different things. Water and hydrogen peroxide, two very different things. So our compounds have a specific ratio of atoms. How we can tell that they are compounds or we have a compound is you're going to see this chemical formula. So if they have a chemical formula, we're going to know that is a compound. All right. Awesome. So those are our pure ones, the ones that never change their composition. They're always the same. So the opposite of that is our mixtures. Mixtures, the composition can change. The composition can be different, right? So it's not the same every single time. Our first one is a homogeneous mixture, and a homogeneous, our prefix homo, means same. So a homogeneous mixture is one that looks the same throughout. Like you can't distinguish different parts of it. All right, we can't see different parts of a homogeneous mixture. Examples of this would be like Kool-Aid, right? Kool-Aid is something that we all make differently, but it looks the same. If we have like fruit punch, if I made fruit punch and you made fruit punch, they would look the same probably. All right. And it also looks the same throughout. When I look at my fruit punch, I don't see the different particles. I don't like see sugar. I don't see the Kool-Aid mix. I see it all as one thing. So that's the homogeneous part, that it looks the same throughout. Then we have our heterogeneous, and this is where we can see the different parts of it. All right, we can see the different parts of the substance, all right, or different parts of our mixture. All right, a perfect example here is like pizza. All right, on our pizza, we can see the crust, we can see the sauce, we can see the cheese, we can see the pepperonis if that's what we're eating. All right, so we can actually see different parts. Another way to think of this is they say, like, if you have different states of matter, like if I had iced tea, the ice in a tea would be make it a heterogeneous mixture because we can see the chunks of ice. Okay, kind of finishing this out by describing matter. All right, we did these on our vocab, we did it on our foldable the other day, so this should hopefully be pretty good, but we're going to quickly buzz through this. So, qualitative is something that can be seen. All right, can be seen. Quantitative is about numbers. We have to measure. There are measurements here, all right? We're talking about measurements, all right? Remember, extensive properties kind of go along with that quantitative, all right? Extensive properties means that it matters how much we have, how much substance we have. All right? Intensive properties mean that it doesn't matter how much we have, it's just the substance that we have. So the identity of the substance determines this. Let's say substance identity. All right? Now, finishing this out, we have our physical things. So a physical property, again, can be seen, easily seen, like the size of a paper, color of the paper, so on. So a physical change is something that just a change in the appearance. All right. And then our chemical property is going to be a property of how it's going to react. How will it react? So you can't really see this just by looking at it. All right. Whereas a physical property, you can see it by looking at it. All right. Then we have our chemical change. And this is where we form a new substance. A new substance is formed. All right, and real quickly, some keys to this, like some keys to a chemical change happening. Number one, you might see a gas or bubbles. All right, if you see some bubbles happening, you have a chemical change going on. You might see a solid forming. All right. Ooh, a color change is a good one. All right, and probably the last main one is heat given off. All right. Okay, there we go. Those are those notes for today. See you on the next set.